Good morning, good afternoon, good evening. So we welcome you on the March 2021 monthly webinar series from Phase 1. We just wait another, I would say 20 to 30 seconds as I see that lots of people are dialing in. But welcome everybody to the webinar. Also welcome Philip and Valerio from IGI.
Thanks, Carsten.
Thank you. Hello.
So I see that the numbers are still increasing. So just wait a little second. Okay, I think now it's fine. Okay, so our today's webinar is made together with our integration partner IGI from Germany, and the topic is advancing aerial surveying and professional photogrammetry mapping. So let me introduce you today's presenters. My name is Carsten Wieser. I'm part of the Phase 1 sales team since more than 12 years. And since quite some time, I'm acting as integrator sales manager. I'm based in Germany, in Cologne. From IGI, I welcome today Philip Grimm. Together with his brother Christian, Philip is leading the company as CEO. IGI has 43 years long history in integrating aerial survey equipment and became a Phase 1 integrator already in 2013. Next to Philip, I'm happy to welcome Valerio Gulli from IGI's business development. Valerio is working in the geospatial market since more than 10 years. Valerio brings a lot of direct experience gathered during working as technical consultant on oil and gas exploration assets and remote sensing applications in the past. Valerio joined IGI during the last year. Welcome again, Philip. Welcome, Valerio.
Thank you, Carsten.
Welcome to everyone.
Before I hand over the presentation to Philip and Valerio, let me give you a short overview about our corporate and products. So Phase 1 is a world-leading provider of digital medium format imaging solution founded in 1993 in Denmark. We provide ultra-high resolution cameras and highly productive software solutions. We operate several sales and support centers for Phase 1 across the globe. In Denver, Colorado, it is for the Americas region. In Cologne, in Germany, for EMEA region and Australia. And in Hong Kong, we operate an office for the Asia and South Pacific regions. Our company headquarters is based in Copenhagen in Denmark, together with our main R&D center. Further R&D and production center, we operate in Israel and Japan. In addition, we have a network of more than 50 distribution partners, which offers a global network of sales and support centers, which makes us a fully customer-centric organization offering 24/7 customer support. Yeah, we really serve the world-leading brands with top image quality and productivity in various applications. Let me now give you a short overview about the Phase 1 aerial products. Phase 1 has been supplying specialized cameras for a wide range of aerial photography applications since 2012. Those cameras are always made on the edge of technology by using the most modern sensors available on the market, delivering always the best possible image quality. Over the years, we have continuously developed these products to meet the market requirements. The journey started with the IXA camera, an 80 megapixel medium format camera based on CCD sensor technology. It continued with specially designed lenses, as well as the first CMOS-based medium format camera in 2014. From that moment, the IXU camera family, with its smaller size and weight, together with many new features, grew our customer install base further. The IXU camera series was then completed by the reliable industry-unique RS shutter system and the Payload kits. In 2017, we introduced the Phase 1 aerial systems, a fully integrated turnkey solution. It contains also our first large format camera with 190 megapixel. In 2018, then, a full new camera series was released, the IXM series. It delivered a completely new camera architecture with even higher capture rates and additional new features. Furthermore, these cameras are equipped with the latest CMOS backside illuminated sensors. Phase 1 is the first company in the market introduced these 150 megapixel sensors 2 years ahead of all other competitors. The IXM camera also brought new possibilities for UAV applications, and the IXM-RS is the new king in aerial digital medium format. Last year, we introduced the PRS 280, a large format aerial system with 280 megapixel and more than 20,000 pixel cross-track resolution. A further addition to this PRS systems is the release of our new flagship model, the PRS 880, which was just announced end of 2020. It is the first phase one large format oblique camera system with 280 megapixel nadir view and 4 times 150 megapixel oblique view. Parallel to these successes, here are the key milestones of our integration partner, IGI. The cooperation between IGI and Phase 1 since 2013 is characterized by a very strong and tight partnership. The partnership is based on a wide variety of activities with a focus to offer the best-in-class customer solution. IGI utilizes and integrates the entire range of Phase 1 aerial cameras since 2013, as well as the Phase 1 image processing and SDK technology. An example of this cooperation is the IGI Urban Mapper from 2016, which marked the first large format nadir and oblique camera system on the market. Another important milestone is the delivery of the main camera system for the German Open Skies team in 2017, a very complex design which contains not less than 24 IGI Digicams, which are based all on customized Phase 1 cameras, specially made for this project. IGI delivers highly customized solutions for the geospatial market as an addition to the Phase 1 PRS systems. The cameras of the IXM series can easily be integrated and used in a wide variety of aircrafts. Due to its small size and weight, the IXM is ideal for all unmanned drones and applications, or anywhere where size and weight matters. The cameras of the IXM RS series with their even higher resolution are part of our Phase 1 aerial systems, but also are built into a wide variety of aerial imaging systems made by many other integrators around the world. These cameras are also often part of airborne LiDAR systems and helicopter-based systems for optical inspection. For the UAV applications, I want to mention we even had a new product release during this week. The P3 Payload Kit for our IXM series cameras. The Payload Kit is a fully integrated solution for high productivity inspection and mapping for DJI M300 drones. It is also available for Mavlink or Pixhawk based drones. The P3 payload contains the camera, a customized gimbal, and a rangefinder solution, which gives the user unmatched productivity and versatility. If you want to know more, please visit our website at the geospatial.phase1.com. The IXM series cameras are often used in drones and inspection applications, such as inspections of bridges and roads, pipelines, railways, wind turbines, power lines, in agriculture and phenotyping applications, and as well as in mapping applications that require highest level of accuracy. The IXM-RS models are mostly used on a larger areas in manned aircrafts, also for mapping applications in agriculture and forestry, as well as environmental monitoring for 3D city models and next to airborne LiDAR systems and also for inspections. So that was my part. So let's welcome again Philip and Valerio, and I will now hand over to Philip to start with his part of the presentation. So I make you
Thank you, Carsten, for this nice introduction and overview. And also thank you for the possibility to present here today. Do I already have a presenter mode that I can
You should use your keyboard. Let's try it.
No, it's not working so far.
Well, you should have. Can you try once more? Now it's working. Yeah.
Okay. Oh, I skipped one. Maybe just quickly go back.
Okay.
Yeah, there's a certain delay, but it's working. Okay. Yeah, so thanks again for the opportunity. Maybe I will introduce myself and also company IGI a little bit. So my name is Philip Grimm, and together with my brother, I'm in the management since 2015. So we are a family business company. My father started the company in 1978. And so far we are already since more than 40 years inside of this market. Also here in the slide, you can see we have on the left-hand side, mission planning, flight guidance, sensor management, and GPS IMU systems. These are basically the core systems that we are producing ourselves. And on the right-hand side, you can see more like solutions-based airborne sensors, which are then the cameras, which we are presenting today a little bit more closely, LiDAR systems, but also mobile mapping solutions, turnkey solutions, where we mostly work together with different aircraft manufacturers to get a complete solution. Or also what has been coming new to the system again is defense solutions with the open skies, what I'm also going to show a little bit. But this has been also starting at the 80s with the first open sky system that we have been delivering at this time. So let me also point out the integration with phase one. So already mentioned, it started 2013. So we are very happy with this cooperation, but also we have a very modular concept, which already started in 2008. This is also one of the biggest parts of our concept, but also the experience for integrating medium format cameras goes back to 20 years of integration. Nevertheless, since 2013, we did the partnership with phase one, and the medium format sensors we are building together with maximum right now up to 8 camera solutions, which are working very positive and very perfect. Nevertheless, we are doing thoroughly testing of each of the camera modes that we get, also with precise focusing, adjustment, and calibration, of course. So in the end, IGI delivers Digicam, or for example, an urban mapper, as we call it. This, of course, gets many different benefits for our customers. So we have a very robust system due to the high experience we have inside of the market. Also then the most efficient systems with the urban mapper, or now also with the urban mapper 2P. I will also show a little bit on this. So there was even an increase in performance for the standard urban mapper to the urban mapper 2P, about 35%. But nevertheless, the urban mapper is also inside of the market since 2016. Of course, we have also a couple of medium format cameras here, so we can also directly support our customer base, even on failures and so on. So fast technical support is, of course, possible, and it's also very important, because we know when there is good weather, everyone needs to fly and has to fly, and the system needs to run. Also, one of the positive things is with the customization, our modular system, is that you can add additional sensors. So not only camera sensors, but also thermal, hyperspectral, radar, or also mostly with the LiDAR in combination. And I will also show in a bit some examples what we have been producing so far. To show a little bit on the concept, basically our standard is that you have an IGI plan software for mission planning. Then you have, of course, the CCNS for flight management and flight guidance, the aero control, which is integrated in this example here in the middle in the camera. And then also the black units, these are the SMUs, sensor management units, where we integrate different kind of camera sensors, as said before, thermal camera sensors or sensors in the end. Altogether is built then really as a system. So we have also our own IGI Visu operating software, which operates each of the different sensors. And then in the end, also with our software for deliverables, Aero Office, IPS, and so on, with third-party software, the customer will get a complete, for example, 3D mesh or a complete deliverable at the end. Yeah, the CCNS, to show a little bit our main core functionality, is also working with our solutions, of course, but we are also integrating different other ones. So standard phase one technology with the IX controller, with the phase one cameras is also working with these units, but also other cameras, LiDAR units are also integrated and working. And it's dedicated to really have a hardware-based system without any touch on it, so that you really have a very bright display and really also haptic knobs to control the system quite easily. It's also integrated with our standard aero control. There are 3 different possibilities right now with the compact, then also with an SMU and IMU unit, or also the smaller OEM version. But what is quite new is also that we have an integration with Planix. So a Planix can be also used with the CCNS5. Yeah, I just mentioned the GPS IMU systems from our side to show them a little bit more in detail. For the compact systems, we have basically two different versions. It's a red box and it's also the blue box. So the red box is basically with a fiber optic IMU inside, and the blue box has a MEMS IMU inside. Technically, mechanically, everything is completely the same. So there also you can start with a lower accuracy model, can go then high accuracy later on and change it just by changing the box. And all is completely done here in-house, developed in-house. So it's also BAFA controlled, but due to the fact that it's export free, there's basically no problem with any exportation and also no ITAR restrictions to these systems. We still have also the possibility to go for an SMU. SMU would be then where the GPS receiver is integrated and inside, and then you can make a combination, for example, like with two IMUs. If you have a large aircraft with two hatches, this could be also possible to put in two of these systems and just control one of the SMUs. And last but not least, the OEM system. This is basically the smallest and lightweight system with only 800 grams. So this is mainly used for UAV applications. Yeah, today we are a little bit concentrating on our aerial camera systems. So in the end, we have a standard medium format, which is then basically an SMU, the camera unit itself, and then also the operator screen with the software, of course, then the large format as we have seen here, and two-in-one systems, which are basically large format and oblique systems, or also customized solutions. For example, if there are two hatches available, like a camera, also in addition with a LiDAR scanner, so can be possible. I will just show a few of our systems so that you have a slightly overview. So it starts with a dual Digicam 300. This is basically a very small system, but still has up to 22,000 pixels across the flight strip. It's integrating the Phase 1 IXM RS150F. So 150 megapixel. You can have two different lens options with 70 or 90 millimeter. And of course, modular system does mean also it's possible to upgrade to the larger format 450 or also to a large format end oblique system like the Urban Mapper later on. And the Digicam 450, this is really the largest format that we have right now. It's also in Gen 2. So basically, we really have an RGBI footprint of 34,500 pixels across the flight strip. Here we basically have 4 of the 150 megapixels from Phase 1 included, and lens options with 90 and 150 millimeters are possible. Also here directly, as you can see in this kind of housing, it's possible to upgrade to an Urban Mapper 2, 2P in the end, also with 150 millimeters in this housing, as you can see it. So this is also one of the advantages of the modular concept. Yeah, next to show also the two-in-one system. It's a Urban Mapper 2P. This is basically largest footprint. So we have the same like the Digicam 440 native footprint with 34,000 pixels across, but then also oblique system included with RGB with completely 150 megapixels. So all of what I have been showing is just for the 150 megapixels Phase 1 camera integrated. We also use the 100 megapixel, but this is then also for the just smaller ones. Smaller systems. So the highest performance is, of course, when you use also 150 megapixel sensors. Here's also different lens options available, 90, 150 millimeters for the nadir part, as with the Digicam 450. But also for the oblique, we have the options for 90, 110, and 150 millimeters. Combinations are also, of course, possible. So, for example, nadir 90, oblique 110 millimeters is possible to really have the same GSD on all different resolutions, nadir and oblique. Yeah, how the system is operated, you can see here, we are normally using a large 20-inch screen to really have all of the different kind of sensors shown on the screen with high resolution that you really have a good overview. You can see here also it's a two-in-one system. So basically nadir part on the left-hand side, oblique part on the right-hand side. Each time 4 of the 150 megapixels integrated into one solution. And it's also possible just to fire the nadir part so that You, for example, can save some shutters if you don't have an oblique project, that you will just fire the nadir part. This is also possible. Of course, we are also delivering some tools for efficient quality control during the flight. This is basically also a part of the IGI Viso software. Yeah, to the end, I would like to show a couple of installations, what we have been doing. So in the end, most of our customers are flying different aircrafts, helicopters, gyrocopters, also UAVs. So it's always that we have to adapt a little bit to the customer needs. This is also not only to the modular concept that we can switch to different sensors, but also installations are a little bit more tricky. Just to show a few, also for the small Cavalon auto gyro installation here with the Digicam 100 and the light mapper. Next slide is coming. Yeah, there it is. This is Cessna 210 installation with the dual Digicam 300. So you can see also the system is really very small. It just fits next to the pilot seat. And it's also possible to fit it inside of this small aircraft. Here's an example of the TechNam. There's the Digicam 450 installed, also together with a LiDAR. So this aircraft is also very efficient because it's very cost effective. Nevertheless, it has also 2 hatches. So even combination with large format and LiDAR is possible in this combination. You can also see here the large screen. So this is also not a problem that the operator can easily then check for all of the different settings of the camera. And in addition, also the LiDAR is then also shown on the same screen. And here you can also nicely see that the camera fits very well inside of the aircraft. Yeah, another example with the LiDAR integration with the Digicam 100 in a Cessna 208 Caravan. This is also very typical aircraft for aerial surveys. Also Cessna 404, now with the newest Urban Mapper 2P, 2 performance in the end. So this is also widely used. A little bit exotic is an Antonov AN2, or how it is called in China, V5. Here also with the Urban Mapper 2 installation. And here you can also see there's lots of space inside of the aircraft. So this is very comfortable to fly and also very, very good because together with the LiDAR, you can also fly very low speeds. Also helicopters. So for example, Airbus AS350 is supported. In this combination here back there you can see the pod. There has been installed Digicam 150 and also together with the Digicam RT for real-time view. So this was also then directly shown live via the internet somewhere else. And also military applications are supported. So here in a Bell 212, this is a combination of Digicam, a thermal camera, hyperspectral and LiDAR in this side pod. And last but not least, the largest aircraft that we have been ever equipping so far, it's Airbus 319. So this is basically for the German open sky systems that we have been delivering. So in the end, 4 cameras, there are lots of different camera models from phase 1 inside. There's been also a special development done from phase 1 for us to really get a large swath width for about 10 kilometers across the strip. Yeah, this is also then my last part, and I will hand over to Valerio to show also some nice examples.
Yeah, thanks, Philip, for this incredible presentation. Thanks, Carsten, also, and the Phase 1 team for having us here today together. I'm very happy. It's very difficult to make a very compact presentation with 43 years of history and multi-branch application on different type of system and high customization. So my idea now also for the audience to show you some of the products, some of the images. As you can see, this is the city of Münster, flown with our Urban Mapper 2 special mission camera, 150mm lenses. This camera is flown in Russia at the moment by one of our clients. So they can capture 5cm GSD from 2000 meters. This project was flown from around 820 meters. from our client Kabel 10 with a Tecna Minecraft. So you can see at the bottom that is a very compact system. That is the native view. I'm not sure I have the right to move in the slides, but maybe Carsten, you can also click for me.
You should have.
Yeah.
Try
Okay.
once more.
Okay, let me try again. Yeah, don't worry. Like, yeah, we can adjust. Okay, thanks a lot. Now I think it's working.
Okay.
Yes. Okay. So I also see that questions are coming in, so feel free to ask. Tina will take care, Carsten, we will also take care at the end. If you want to discuss anything else in the next stage, you will also have our email addresses, so feel free to be very engaging, ask if you see something that maybe that you want to know, just get in touch with us. So you had, before you saw the image, of course, from imagery, you go to products. Our clients are high demanding. Usually, when we have our consulting session, the drivers are very close to be ultra high resolution, so to be the best in the market. We have company like Cairo West in Germany opening up the market for the 3D city modeling, 3D GIS application, flying already oblique system from 2016-15. In the background, you have an image of 2 centimeter resolution already from 2016 near infrared. So high resolution, flying efficiency, productivities, these are usually the drivers that our clients discuss with us quite openly. Of course, then in the production, you can generate automatically different type of products, including 3D city models, mesh, texture mesh. As you can see, the quality is very ultra high resolution. You will have also a feeling later. So I will move directly into the mesh at the end of my short presentation. What we want to highlight here is that by combining oblique and native imagery, so photogrammetry only production, you can really generate a high resolution mesh model or true ortho or DSM. In this case, we're presenting results from PhotoMesh, one of our partners. We keep an open format in our imagery and products, meaning that our clients can decide which is the best fit for their production. Of course, we can also advise them to make sure that they really can achieve targets and products and quality that they want to deliver to their clients. So we really work closely with our clients, and thanks to the fact that you have an open format, you're like our clients are quite happy to also do benchmarking and select the best possible solution that is fitting in their production line. This is an oblique image of the same cathedral that we will show you in the city model later on. As you can see, it's in high resolution. You're also invited to join me or to write to Philip or to us or to have some inspection directly on the imagery. You can clearly see people walking, shadows are coming out also very nice. There is no noise, high dynamic range. So our system are dealing very well also in challenging lighting condition. Really fast, 0.5 second repetition rate, meaning also that you can get 2 gigapixels per second. So in a very efficient and productive way. What is so special is that it's made based on a modular concept, meaning that you have a wide area mapping application thanks to the largest native footprint in the market. So you have more than 34,000 pixels across for 450 megapixels in total. So our clients can be very productive, and they can save up to 40% of flying time compared with standard or let's say commercial system with a small native footprint. Of course, the native part is really important for true ortho production, and this is why AGI has been working very closely with different image processing and computer vision company in the past to really understand what is needed for our clients and what they need to acquire in order to be efficient and to keep the leading place in the market. So you can collect native oblique imagery. Usually our imagery are well known in the market for the superior image quality, resolution down to 2 centimeters per pixel. In this case, you are taking a zoom in view into an antenna. As you can see, it's fully reconstructed. Even the people are coming very nicely in the scene, and this antenna is less than 5 meters in height. less than a meter in width. And I will show you that the antenna is fully reconstructed in the model in a completely automated fashion. So there is no editing or retouching, it's just out of the box production. This is a true ortho. What is so special about a true ortho is that it's giving, as you can see, a vertical view of the Earth's surface. There are no building lean, so it's a very viable products for different type of GIS application, for cadastre application, insurance applications. Together with the DSM, you can also run machine learning, feature extraction, and with these high resolution data sets, might be a note here, in particular if you're working with drone imagery, very often our clients are thinking that this is a drone data set because you have a resolution of 2 centimeters. So drones technology, we also have clients and we can also build system for UAVs, but in this case is our Urban Mapper 2. So it's a sensor that has been flown in a manned aircraft, and you can go down to very high resolution thanks to a special constellation with very long focal lenses. So it's not drone imagery, and I often receive this comment, so I want to highlight here that it's really a 3D mesh. And you can also see that it's the cathedral that I was showing at the beginning, coming completely and fully reconstructed without the use of LiDAR data. And it gives really a nice and realistic feeling. Also in the shadows, geometries are coming out very nicely. I like to show, and I will show to you the nice part and the critical part, which I know quite well, in particular thanks to our clients that can openly share feedback with us. So this is a nice close-up view. As you can see, even the street is fully reconstructed and coming out in a very nice and sharp way. Minor details, complex geometry, fully reconstructed, no LiDAR, so really based on oblique and nadir imagery, processing photo mesh in a 3.5 hours. So you can run the project. This is not really a large block, but quite sizable. So we are around 1 terabyte of data by processing in the cloud with distributed processing. It can be done in 3.5 hours. In this case, I'm not sure really about the number, but I think it was 43 nodes running in parallel. So really fast production, really high resolution results. After this slide, and I think I'm almost done with the slide, so we will move into the Mesh Inter Explorer. You can even see that the people are fully reconstructed, cars also in the shadows. You can see that the tree, and in particular here, you can see that it's a real 3D mesh, so it's not a thin model or simplified geometrical model, it's a real 3D reconstruction. So you can see the vegetation going down, you can see the ground, and you can see all the geometries as well in the scene, and people also reconstructed. So thanks to the high resolution of the imagery and also quality. Okay, Karsten, if you allow me, I will share my screen and I will directly go into the mesh display.
Okay, so you should have control.
Yeah, just let me know if you can see also my screen.
Yep, can see it.
So I'm picking up exactly in the same scene that I was showing you before. So we are now in Inter Explorer from Skyline. As mentioned before, we have different type of technical cooperation with many companies, including Skyline. So our clients are familiar with the production, with the products, what we can use. We also work with other companies like Info. So it's really up to the client, and we offer just an open format so they can really decide that we do a lot of consulting together. This example will be entirely based in Skyline and based on the Urban Mapper 2 datasets. So you can see that the street is coming very nicely. I will switch also to show you that it's a real 3D mesh, so it's not. So you can see also the wireframe coming out and the density. And usually what is also really nice to see for me, and this is a very special model with this resolution, all minor details in the facades, then thanks to the oblique system and the calibration and accuracy are coming out very nicely. Rooftop are coming out very sharp. Street level view, also you can see that the DSM and from the screenshot I've been showing before, also the two are coming really sharp, and you can see that you have a very nice combination. Sharp, flat, really nice, no editing, so completely automated production. And it's also an open invite here with our partners also. We are looking for more integration from aerial, also with mobile integration. So if you have any idea of projects, we are very happy to discuss with you to do an integration of mobile and this type of aerial imagery that will enable you to produce this type of models. I was mentioning before about the model and about 3D application. This is just something quite easy that I've been running before. I will go back again just with the texture mesh, so you get a better feeling. You can run 3D application, view shed analysis. Let's say some application also for terrain profiling. You can do point to point, and you can see how the terrain is extracted. Let's see a little bit about the geometry. And I want to invite you also to start to make your questions. And this format is about 45 minutes, so we're getting close. We still have time, and I will keep showing also the mesh during the QA session. But for now, this is the part I was showing before in my slide. You can see that the geometry also in the shadows is perfectly reconstructed. Also, thin geometry on the top of the cathedral are perfectly captured and reconstructed in the model. This is a market area. So you have different type of geometry, but what is really stunning and what also make a very strong case for photogrammetry application with this type of quality and precision in the imagery is this is a textile, so it's not a very structured surface. You can see that it's a bit moving, can be by the wind, and it's fully reconstructed and coming out very nicely in the scene. Again, before I was discussing about the trees and the fact that it's a real 3D model, you can see that is reconstructed, and you have the crown and going down to the street level. So vegetation is also coming out very nicely. And here we are to the telco antenna that I was showing before in the model. You can see that this all also perfectly reconstructed from both view. In the shadows, I would like to highlight that we have very low noise level, and thanks also to the very high dynamic range. So it's really fast sensor dealing perfectly also in challenging lighting condition. And as you can see, I think this is also a very nice statement coming directly from the results. Different type of geometry, even people, you can see that they are sitting. You can see if there is a mug or something else on the table. And I will link also with the scene that I've been presenting before. So you can see also on top of the roof, all complex geometry coming out very nicely, very true to life colors, thanks to the quality of the imagery. So you really have a nice variation, which gives you a real feeling. And here is the scene which we have been showing before from the presentation. So let's say from presentation to real model. I will go back to the wireframe, so you really get the feeling that it's a real 3D city model. Yeah, so you can also move, of course, for your presentation, but there are also a lot of tools, and we will have more webinars also with our partners to showcase more in the future. So yeah, we would be really happy to go also through the questions. We have still 5 minutes. I will keep showing you the model and in different parts of the city. So we started in this part. You can see also this top completely reconstructed. So it's a ultra high resolution model. And very often I don't share that is captured with our urban mapper. So I wait for the feeling of our clients, and they say, oh, that's flown with a drone. Of course, and then I have to say drone is not allowed to fly above densely populated urban areas. So this is actually urban imagery. 2 centimeter resolution thanks to our special sensor. You can see even glass surfaces are perfectly reconstructed. So overall, it's a very good 3D model. You are invited to engage with us, also to receive the true ortho, the DSM, the point clouds. We can go case by case depending on your needs. So that's it from my side. This is what we have been trying to show you today. So end-to-end system, IGI is also building the positioning part, which ensures that you have very high accuracy and precision. And very special type of sensor. So you have different type of application from high resolution mapping, engineering mapping, defense application. So we can be really modular, flexible based on your needs. And maybe what to mention here is also we are not involved in data content program, meaning that our clients can very openly talk to us, engage with us, because we know that they will do the flights anyway. And they also have the freedom to ally their needs, and very special customization can then be brought to the market. So we are very open. There are different type of lens constellation. In this case, you are seeing a model with the Urban Mapper 2 special mission, which means 150 millimeter lenses. We are also building 90 and 110 millimeter lenses, but we also have different type of selection with near infrared, which is coming as a standard. Okay, Karsten, I don't know if you want to.
Thank you, Valerio.
Yes.
Thank you for all these nice examples you have showcased here. So very high resolution and a good 3D mesh, very accurate. Thanks a lot for this. So I think we now move on to the question part. So Tina, did you have collected some questions during the webinar?
Yes, yeah, thanks again to Karsten, Valerio, and Philip. We do have a few questions, and we still have time to answer these. Let me start with the first one, which is asking, what quality control of the flight do you have? I think that's for Valerio and Philip. Yeah.
Yeah, flight control. So there are a couple of different features inside of the IGI Viso software. As a standard, we have a histogram. We have, of course, also a blur control for the FMC. There's then also aperture possibilities to check on these. So a couple of different things. This was just quickly shown. Maybe we can show this also in a different solution somewhere more further. But also it is possible to go in kind of history, so that you can basically, while flying, just stop on a certain image, and then you can toggle also inside of the images that you have been already taken. So all the previews that are basically coming in, you can also directly check during the flight.
Thank you. The next question is asking, is it possible to install a Digicam 450 in an external port if no hole is available?
Yeah, I can also answer to this. Basically, yes, should be possible, but we need to check, of course, what is the payload and so on. So basically, it should be around 40-45 kilograms for the camera. Sometimes also the higher part with the SMUs can be put to a side, can be put somewhere inside, so it does not need to be inside of the pod. And then, of course, we need to check if a direct installation would be needed, or if we can also use the stabilized mount. So this we can check. We just need to have the measurements and the details, and then we can check it.
Thank you. I think the next question is for Valerio. What overlap did you use during that 2 centimeter flight?
Yeah, thanks, Tina. That is an interesting question, because we also consult our clients. So usually for this type of CD, you are around 80-65, 80-60 overlap. We suggest to have for automatic through ortho, DSM extraction, like production, 80-60 overlap will do a very good job. Of course, if there are CDs, and we can also showcase to the person that have been asking, we also have CD like Frankfurt, so overlap in the central part, or a CD where you have high-rise building. So maybe in the really central part, ACT 60, 80 is advised if you want to do fully automated production for the mesh, let's say. But usually our standard advise that what we see from our clients is already that 80-65 overlap is more than enough to produce very high quality products in a fully automated way.
Okay, thank you. And I think the next question again is for you, Valerio. Did you use the internal AT of Photomesh or something like Bingo or Info? How many ground control points did you have?
Yes, thanks a lot for this question. So what you're seeing now is not using ground control points. So we really did an automated production in this case back a few months ago. In this case, we're using directly the IT from Skyline, which is a very strong IT. So both oblique and nadir imagery have been used. But of course, we have also clients using Info Mesh IT, for example, through ortho production or mesh production. So it's in this case, it's just the Skyline IT. So there was no use of ground control points, no use of third parties or additional support on the IT, just the IT, pure IT from Skyline.
Maybe I can also add, because this is a demo data set that we have from Münster. So the raw data are available, also kind of process data are available. And if there are any certain tests of interest with different kind of software, this is of course also possible.
Exactly. So feel free to engage, and in this case, we can also share sample imagery, meaning that you can do directly an inspection on the imagery, nadir, oblique, and we can also support you with benchmarking or processing, and the data is available. So you can directly look at the results, and you can have a real feeling also of the high quality of the products.
Okay. Next question. I see that the roof consists of several unneeded tint triangles in the mesh 3D model. Can a simple saddle roof not be vectorized as 2 polygons to reduce the bytes?
It's a very nice question, technical question. I will pass it to Skyline in this case because the results have been made with the support. Of course, you can also simplify the model, but have to say, like, you know, when you go really far away, and this is also showing is a simplification of the model, but when you zoom in, you can see that it's a very dense reconstruction. And this is also ensure that when you have a nice close-up view, so maybe I will just remove it for now, you can see, let's say that if you are on top of the geometry, okay, I lost the screen. Okay, no problem.
So now it's back. Yeah.
I was just saying, Tina, maybe to address this, yeah, you can also simplify the geometry, but you can see that here, thanks to the height details and the dense reconstruction of the model, all roof and facades are coming out very sharp, which is very important. And in this case, we have an output resolution, which is matching the input resolution, which is something that I really like to see. So it's 2 centimeter. And the model is based on this. Of course, by simplification, you can also change the output resolution or changing the density. But I would say this is now the output GSD here is also 2 centimeter, around 2 centimeter, let's say.
I can also add to this question that we concentrated here on the automatic mesh that has been produced, but it's also possible with different software like Rhinoceros, Rhino City, to really build also a waterproof CAD model, and then you have also possibilities to just take these things a little bit easier to reduce also the meshes.
Yeah. To add, maybe we did also building extraction on the meshes. I didn't plan it for today, but there will be also more session coming, and we will also show a bit more about what you can do really with the mesh, not just for application with ViewShed, but also for cadastre applications or building extraction. And thanks to the high accuracy and quality of the model, as you can see, everything is really sharp and nice and fully reconstructed. The building from the cadastre are matching almost perfectly with the building that we have reconstructed. So that is also something that Philip was mentioning before, and we're very open. So get in touch with us, and we can also work on special use cases.
Thank you, Valerio. Sorry?
Yeah, I just want to ask if you have further questions. Yeah.
I do have a range of further questions, but maybe let me just ask the next one. First of all, what would be the amount of data per square kilometer? And on the side notes, it would be who would use, or which clients would use this system you're showing on large areas?
Okay, I will I cannot really say about the square kilometer for data. I don't really get it, but usual clients. So our clients, like I mentioned, company like Airbus, we have also covered them. We have many clients like around Europe and other companies. Of course, they usually work for municipality. They also, okay. So do you want to, yeah? I will pass it to Philip because I cannot really read well. But
yeah, I can just add that I know from our customers, basically they derive about 1.5 terabyte or up to 1.5 terabyte of data per hour. So per hour is basically then somehow the calculation. I'm not sure how much this is then in square kilometers. So this would need to check, and can we answer maybe later on?
Yeah, we can double check, but you have a lot of storage. So usually our clients also can fly multiple missions per day. You were saying also about clients, and clients can be private engineering companies, flying companies, aerial surveying companies, and they're serving municipality in Germany or around the country, Netherlands, like Cadastre. So it's really a variety of clients thanks to a very diverse portfolio. So also military application thanks to this very ultra resolution use case, so that you can go below 1 centimeter, below 2 centimeter, let's say 1.5 centimeter. We have to think also about less than 1 centimeter is possible already, but not from 800 meter. Yeah. More questions, Tina? Or and everyone is
many more questions. So I'm relying on Carsten here to guide me, but I'm happy to ask some more. So another question would be, could you please share some examples of the system on UAV platform application? What kind of setup Phase 1 common IGI system are available for UAV?
Okay, just send us an email, and we can also showcase what we can build or can offer for a special UAV or military UAV or different type of application. So it really depends on the use case, but we are very open to receive an email.
On Phase 1 side, I can add here that we have the release of the P3 Payload Kit released this week, which is for smaller drones, multi-rotor drones, a payload kit which can be integrated in a couple of different types of drones, and deliver also here a possibility for high accurate mapping as well for inspection topics.
Okay. Then we have 2 more questions in regards to first, how are the cameras calibrated? Is there a relative calibration between them? And the second part of the question would be how many images were taken to generate the example?
Okay, for the calibration, is the audio fine? So for calibration, yes, of course, every client. So we are talking about photogrammetry grade surveying or engineering surveying. So you receive a camera calibration certificate. It's not done by me. We have also an R&D department. There's Jens Kremer or my colleagues from the R&D. So every camera is coming with a calibration certificate, of course, photogrammetry grade. So you receive all information directly from us for each sensor that we're building. You get also a certificate. And what was the other question, Tina? How many images? This block. So now I don't have by heart my the number. So let's say it's about a bit less than 1 tera input data. I think is around 85 nadir. I'm not sure about oblique, but I will be very happy to receive this email. So feel free to contact me, and you will receive not just the answer, but also the images together for inspection. So you can take a look directly at the demo dataset. It's not so big, but just for a special use case. We also have very large datasets flown by our clients. So the cameras is suitable for special use cases, city-wide acquisition, like entire city of Berlin, and it was presented already in previous webinar, but our clients can fly entire country in a very productive
Thanks, Valerio.
way. Yeah.
So I'm going to ask another question now, and I think the other questions, because we have many more who would obviously run over time, we're going to answer all the other questions via email directly. So the last question for today is, could you give the parameter for the 2-centimeter flight, the speed, the altitude, and the length overlap?
Yes, of course. So it's, in this case, we are about 820 meters. Flying speed around 100 knots, 80-65. So this project is around 80-65, 80-60, I have to check. But flying speed around 100 knots, a bit more with a Tecna aircraft by Cabel 10. So you can also engage with Cabel 10 because this project was flown by them. And flying speed, so I already said, overlap 80-65 and 2-centimeter GSD from 820 meter with the Urban Mapper 2 under 50 millimeter lens constellation.
Okay, thank you, Valerio, for this explanation and question answered. So yeah, as said from Tina, we're running a bit out of time, but we will all take all questions which came in and answer them offline by email. So you will get some more details later on. So and then would close the webinar for today. So thank you to all the viewers for joining this webinar series. Looking forward to seeing you again at the next webinar. Like always, the webinar is recorded and will be provided here within the next 2-3 days on our website. So you can go back and view it again or reference it to someone you know that also want to see it. Yeah. So thanks again for all of you visiting. And also thanks once more for Valerio and Philip for all the explanations. And yeah, have yourself a wonderful and great day. Thanks a lot.
Yeah, thanks, Carsten. Thanks for having us, and thanks for watching. I hope you have enjoyed the session. Get in touch with us, and we can proceed in the following days as well if you have more questions. Thanks, and have a good evening.
Thank you also from my side. Have a nice day. Bye-bye.
Bye-bye.
Bye.